the chain rule. Now we can see that the change in y over a change in x is equal to change in y over the change in u multiplied by the change in u over the change in x. This acts like little fractions, which obviously you could cancel these out if there were actual values in here. But we're going to look at the instantaneous change. Before we can do that, we have to look at what delta u is. The delta u can be expressed as change in u, the change in x multiplied by the change in x. So again, these will cancel out. Now, taking the limit to both sides of this, now as delta x goes to 0 on both sides, right, we can then split up this limit into two limits. That is, a limit as delta x goes to 0 of delta u on delta x multiplied by the limit as delta x goes to 0 of delta x. Now we can see that this one here, right, this one, that must go towards 0. So of course, if that goes to 0, that means that this will go to 0. And obviously, if delta x goes to 0, then delta u will go to 0. And this is a very important part of proving the chain rule. Alright, now taking this part here, and we'll take the limit to both sides here. So the limit as delta x goes towards 0 of the change in x over the change in y equals the limit as delta x goes to 0 of the change in y over the change in u multiplied by the change in u over the change in x. And again, we'll split these limits up. Okay, and we can see here that what I've done is, you see this little part in here, I'll just emphasize that. That little bit in there, we can't proceed until we change that to a u. But we know that works. So if delta x goes to 0, delta u will go to 0. That's what we've proved over here. Now, then what we can say is that the limit as delta y on delta x will be equal to dy dx. The limit of delta y on delta u is dy du, and the limit of delta u on delta x is du dx. So we can say the chain rule is that dy dx equals dy du multiplied by du dx. This is a very important rule, and I'll be doing some examples showing how we can use that rule in the calculus.